Hello, this recording or this video, I am going to show you how to reverse engineer an Android application, as well as using dynamic analysis to change values of an application while it's running. So the tools we're going to use are the Intro to Android Security Virtual Machine version 2.0.1. This is a virtual machine that I created. And we're going to use an Android x86 virtual machine, which is an Android emulator. So what it does is it emulates an Android phone. So these are the two tools or virtual machines we're going to use for this video, along with some other tools inside the virtual machine. So let's get started. I'm going to start the virtual machine Intro to Android Security. And while it's booting up, we're currently on the second version because the first version, I underestimated the space needed. So with the second version, I revamped the virtual machine and built it on top of Vagrant, and it has way more storage. It has 128 gigabytes of storage. And with my first version, I think I had like 15. And I found out very quickly that wasn't enough with having people adding tools, and then as well as hacking, that was like nil. So the second version, you can hack to your heart's desires because, as I said, we have so much storage. So now we're at the login page and the user is Android. And the password is security, lowercase, and we're going to press enter. Okay, so the virtual machine has started. And we're going to open the README. And this README describes everything that you, the user, needs to know about this virtual machine. It's the second version, as I described. I want to give a huge shout out to Android Tamer, which was the inspiration for my virtual machine Intro to Android Security. I had a mobile workshop in 2019 with Diana Initiative, and I was like, dang, I need a virtual machine, to do my workshop. And I found Android Tamer, but it was severely out of date. So the creator, we chatted on Twitter, and he gave me pointers on how to create my own virtual machine. And here we are. For version 2, I was also inspired by StuNet. They have a Try Hack Me Android room, and I noticed that they had tools that I never played with. So I was like, hey, I want to add those tools to my virtual machine, which is what I did. And again, so I'm not going to talk about all the tools that are in this virtual machine. If you want to know, read this README. And it will let you know, all of the tools, how to access the tools, and if there's any funky or special things you need to do, it will describe that as well. So now, let's open the Android x86. And this is the emulator, the Android emulator. And we're going to go to debug mode. And the reason why we're going to debug mode is what I found sometimes is when you use the emulator, it doesn't pick up all of your settings, like your network settings, Wi-Fi settings. And we need this because we're going to need to connect to the internet, and we're going to need the IP address from this Android x86 emulator because we're going to connect it to our Intro to Android Security virtual machine. So right now it's hanging. So if you press enter, if I type exit and exit again, the script will continue. Yeah, I know that's not real intuitive. A few times when I was first doing this, I was like, why is it hanging? And then I had to go to Google, and it was like, hey, you have to press enter and then exit. Not super intuitive, but wanted to call that out. And the emulator is getting all of our settings and doing a whole bunch of things. Now it's starting because we have the Android screen, the boot up process. Okay, sometimes you might get this message where it's like, hey, the system UI isn't responding. Just click on wait. And I should add a caveat that with this emulator, make sure you are using a lot of memory. I would say between a minimum of like 4 gigabytes if you can to have it run efficiently. So we're going to click the button with the 6 dots, which is going to open our tasks, and we're going to click on the terminal emulator, and we're going to type ifconfig to get our IP address, and we're going to look at the WLAN or wireless LAN local area network, and we see we have an IP address of 192.168.1.92. We need to take note of that. So now we're going to go back to our intro to Android security. And I guess I should explain what's in this virtual machine, right? I added additional folders such as dynamic analysis. I mentioned that a little bit. We're going to use Frida, which is a program where we can change values while an application is running. We have manual analysis with APK tool. We have penetration testing where we can hack all the things. And we have Burp Suite, Nikto, Nmap, SSL Scan, Wireshark, and Zap. We have programming with Python and SQLite. We have reporting with Cherry Tree and KeepNote and reverse engineering. We're going to do this as well. And we have JADX CLI or command line interface and JADX GUI or graphical user interface. So now let's add, along with JADX GUI. So now let's go to the Android home folder and we're going to click on directories. And here I have included insecure Android apps for you to play with if you download my virtual machine. So we're going to crack UnCrackable level 1, but I also have level 2, level 3, level 4. These two are level 4. I also have Diva, which is another insecure app, and IG Learner. So when you download the Intro to Android Security virtual machine, you would not have these two files. I created these files for the lesson for today. I created them just to get it out of the way. So you won't have these two files. So if you have the virtual machine and you're like, hey, I don't have the disable root or disable root 2, you won't have it because I created these files after the fact. Also, we have the MSTG Hacking Playground, MSTG Mobile Security Testing Ground from OWASP, the Open Web Application Security Project, which is a nonprofit organization where security professionals, practitioners, enthusiasts help to make security better in all facets of life, whether that is mobile, web, Internet of Things, smart devices. It does all the things. So if you're interested, go to OWASP.org. So now we need to put our UnCrackable Level 1 app onto our emulator. So how do we do that? Well, we're going to go to menu and type terminal and click on Mat Terminal. And then what we're going to do, we're going to PWD or print working directory. So we see we're in the Android directory. So we're going to change, and I want to say documents. And then if I do a ls, which is a listing, you should see that these listings match what's in here. So that in this directory. So it lets us know we're in the same directory. Now, Remember how I said we needed to keep track of the IP address from our WLAN 0 from our Android emulator? Well, I said that because we're going to need that IP to connect to our Intro to Android Security virtual machine. So what we're going to do is we're going to type ADB for Android Debug Bridge connect. We're going for connection 192.168.1.92, or the IP address from the WLAN section when we executed the ifconfig command inside of our emulator. And pressing enter, we see that it has connected successfully on port 5555, which is the default port for ADB, or Android Debug Bridge. Now we're connected. So our virtual machine, our Intro to Android Security virtual machine, is now connected to our emulator. So we're connected, so they can talk to each other. Now what we're going to do, we're going to say ADB install and then I can press tab to do autocomplete. And you notice it just did UnCrackable level because we have 3 levels. So Linux is like, I don't know which one you want. So I'm going to type 1 and press tab for autocomplete. So what this command is doing is saying, okay, hey, now that we're connected to our, in this case, our emulator, install this app, UnCrackable level 1, to our emulator. Pressing enter, we see it's thinking, and we have success. Yay! So it is there. And we can prove that by going back to our emulator and pressing the circle to go back to our home screen, pressing the circle with the 6 dots, and we see we have UnCrackable 1. So our app successfully installed onto our emulator. So let's open it. So I'm going to double click, and we received an error. Root detected. This is unacceptable. The app is now going to exit. So you may be wondering, what is root? So root, or rooting, is a concept in mobile devices where essentially you operate as the super user or the administrator. So when you are root, or you have root a device, that means you could do anything on the device, right? So in most cases, when you purchase a phone, it is not rooted, meaning you're a standard user. You can do certain things on the device, but other things you cannot. And this is to have good security. So it's like, for most users, I say about 85% of users, they really don't need to change configurations of their cell phone or mobile device. They get it, they use it to make calls, to get online, whatever. And, they're perfectly fine. The other 15%, I would be considered in that 15%, likes to walk on the wild side. And, I want to configure my phone my way. So in this case, I would need to root my device to, do some things, allegedly. And so the Android operating system is built on top of the Linux operating system. And with Linux, root is the super user or administrator. So when you're root, you have the keys to the kingdom. You can do whatever you want in the operating system. And it's the same thing with mobile devices. If you're root, or if you have rooted your device, you can do whatever you want. No one can stop you. I should do a quick caveat. If you do root your device, let's just say you have a phone, from the standard providers of like T-Mobile, Verizon, AT&T. If you root your device and you have a warranty, you have effectively voided your warranty. Okay? It is in the fine print. So if you're going to do mobile hacking, don't do mobile hacking on your primary mobile device. Buy a new mobile device, a cheap mobile device, or use an emulator. But don't use your primary phone, because if you root it and you have a warranty, you have effectively voided your warranty. So I just want to do that little PSA. Okay. So we can't go any further because the application would not open, because it's like, yo, you know, you're trying to have the keys to the kingdom. We don't allow that. I'm stopping you. So the only thing we can do is press OK, and the app closes. So remember, I mentioned in the beginning of this video, we were going to do dynamic analysis. We're going to do that a little later to bypass that error message. But now we need to know how that error message was constructed. And the way we're going to do that is we're going to reverse engineer the app. So the way we're going to do that is we're going to go back to our intro to Android security virtual machine. We're going to go to menu. We're going to go to reverse engineering, and we're going to go to JADX GUI, because we're going to use the GUI, or graphical user interface version. And this is going to open. And let's talk about the supported files. So it has JADX, APK. So you may be wondering, what is APK? APK, Android package, DEX, which is a DEX file, JAR. JAR files are created when you program in Java, and you can have a Java program and send it as a JAR to execute. Class, Smalley. Smalley is, if you have computer science experience, you would be familiar with assembly language, which is like the bare bones of programming. Every computer language can be broken down. Every computer language can be broken down into assembly. You don't program in assembly. I've done it about close to 20 years ago when I was in college. But most times you don't program in assembly because it's very nuanced and it's easy to mess up. So most times you'll program in a more readable language, such as Java, Python, C++, things of that nature. So Smalley is the Android equivalent of assembly language. Zip, which is a zip file, AAR and ARSC, I really haven't used those, so I can't talk to those. But in the comments, if you know what those are, drop it down below. So now it's saying, hey, which file do you want to open? We want to open the UnCrackable level 1. And we have successfully reverse engineered the application. Kind of easy, huh? Cool, huh? And you might be wondering, well, how did you reverse engineer it? Well, I know I reverse engineered it because I can see the source code. Now, I should give a quick caveat about reverse engineering. With applications from companies or developers, and if it's proprietary or if it's for profit, you really don't want people to reverse engineer your application. You don't want to reveal your source code, because then people could modify your source code and then re-upload their version of your application to the store. For instance, for Android, the official repository is the Google Play Store. So if you have an Android device and you download applications, you go to the Google Play Store. So if I'm a nefarious person and I'm like, hey, I see Facebook and I reverse engineered their app and I can deduce what's going on, and it's like, you know what? I'm going to change functionality to where instead of the username and password goes to the Facebook server, it goes to my server. And so what happens then is anytime someone downloads my version of the app, I can see your username and password and log in as you. Kind of scary, huh? So a way to mitigate this, what developers and other people do, is they obfuscate their code. And what that does is you try to make the code as unreadable or illegible as possible. So that way, if I'm trying to reverse engineer your app, it will take me a long time to deduce what your application is doing if I can do it. So I'm saying all of that to say because it's going to come up later. Now, with Android apps, the Android app needs to have a main activity. This main activity you can think of as the entry point to the application. Every Android app that you use has a main activity. That is the entry point to the application, and it has to be there. If you don't have a main activity, it will not work. Your application will fail. So now, scrolling down, okay, we can read this code. It's legible. And it's like, okay, so this isn't obfuscated. Scrolling down, though, line 32, we see this onCreate method. And we see this conditional statement. If C.A, C.B, C.C, root detected. Sounds familiar. When we opened our UnCrackable app, it said root detected, cannot proceed, going to close app. So it seems here, this is where the root detection is being checked. Now, this code is being obfuscated because, as you can see here, we can see methods and classes, but here C.A, C.B, C.C. What does that mean? C. What is that? A, B, C. What is that? What are those? So if we click by, I'm trying to do it. Okay. Yes. If we hold down the control button and then hover over the method and left click, we are now officially in the class. So I guess I should have mentioned this a little bit before. Android is written in Java. Java is a programming language. So at the top of each file, you have a package which describes, a bucket of particular files. So in this case, the package is sg.vantagepoint.a. And we have a class, and it's public. So with classes, you can have public, private, and protected. Public means it's open to everyone. Private means it's only open to it's private and it's only accessible to the particular class. So it's class. And then protected, I believe, is visible to every class in the package. So this is public, which means it is open to everyone, right? Any file in this application can use this C class, right? Okay, so looking at this C class, we see we have 3 methods, and we can tell they're methods because they have the parentheses here, and they're Booleans, which means that it returns true or false. So a Boolean is only 2 values, true or false. And the static here means it doesn't, it stays the same. So it's, public, meaning that it's open to everyone. Static. Boolean means it returns true or false. So if we look inside the A function, we see we have a for statement. So it's a loop, and it's like, hey, we create a string for string inside system.getEnvironment. So we're getting the path environment, and we're splitting it by the colon, because if, for instance, I can show you inside of the intro to Android security. So if we open another terminal, and I can say echo path, which is a environment variable, you see that there are colons here and that is the way to separate directories. So what we're saying is, hey, for every item in the path environment variable, split it by the colon, and it says we're going to create a new file, and if the SU, which is switch user, and if you use in Linux, if you use just SU or SU with no user, you are trying to go to root or elevate your privileges to the super user. So it's saying, hey, we're going to create a new file, and if we see SU or switch user, if that exists in this new file that comes from this environment variable, return true, which means, hey, this person is trying this application, or this person is running as root. So return as true. The second method, or B, is saying, hey, we have a string from build tags, and this ampersand is an and operator. So it means it has to be null, and the string has to contain test keys. And it's saying, hey, if this is, if both of these are true, then the string is true. So what we're saying is, hey, if, let's just say it's null and the test keys doesn't exist, then this will return false, right? So both of these have to be true. For C, it's kind of similar to A, but a little different. We have another for statement, and we've defined a string, and we have a new string array. That's what these brackets are. And we have particular files and that we're looking for. And it's saying, hey, we're going to create a new file. And if any of these files exist, return true. Because then that says, okay, you're trying to run as root. You're on a rooted device. So essentially, we're going to have to use dynamic analysis, or in this case, Frida, to bypass these checks. So right now, when we execute the UnCrackable level 1 application, one of these methods are returning true. So we need to have all of these methods return false, and in that way, the application would think we're not rooted. And we can prove that here, because on line 33, it's where it's doing the check. And these pipes here are OR statements, meaning only one of these have to be true. So C.A could be true, C.B, C.C could be false. This will still be true. C.B can be true, C.A, C.C could be false. This still will be true. C.C can be true, C.A, C.B can be false. Still true. The only way this is false is if all three of these are false. So now, we need to do dynamic analysis, and I mentioned this earlier with Frida here, with the Frida tool. But how are we going to use that? Well, first, we're going to go and we're going to say inside our terminal Frida version, because we need to know what version of Frida we have. This is very important. So if we try to use, we have 14.2.11. If we try to use version 13.2, it's not going to work, because what we're going to do now is we need to download the Frida server and put it on our emulator. Remember, our emulator and our intro to Android security version 2.0.1 are talking to each other through this ADB Android debug bridge connect. So what we're going to do, because we know our version of Frida is 14.2.11, we're going to open the Firefox icon here. And we're going to go to google.com, and we're going to say Frida 14.2.11 Frida server, because we need to get the server 14.2.11, and we're going to press enter. And here we're going to go to the first option of on GitHub of Frida. and you see Frida.2.13, that's not our version. Frida.2.12, not our version. Frida.2.11, our version. Okay, so we're going to click on Assets to reveal. And we're going to scroll down to Frida server here. And now we see we have a whole bunch of Frida servers. Which one do we want? Well, we have an Android emulator. So we need to do the Android x86-64. And I'm saying that because the Android emulator that I have is x86-64 or 64-bit. And we can prove that by saying adb devices-l. And you see here, it shows we have a device attached at 192.168.192, port 5555, which is the standard port for ADB. And we see here Android x86-64. So again, if you're not sure which version you're using, if you have a different emulator, once you connect through ADB, you can say adb devices-l, which will show the devices in long form, so all information, and it will tell you which version or architecture that you need. So we have Android x86-64. So for Frida, we're going to say Frida server 14.2.11 Android x86-64. We're going to click on this. We're going to say save. We're going to say OK. Okay, it has officially saved and downloaded. Now we're going to go back to our terminal. We're going to go here. I'm going to go to the second terminal. Now, PWD, we see we're at the Android home, Android documents directory. So now what I'm going to do, I'm going to say CD, which is change directory. I'm going to do a tilde, which is going to point to my home directory, in this case, home.android, and I'm going to say downloads. And if I do a ls or long listing, we see here we have our Frida server 14.2.11 Android x86-64. So now I'm going to go into the GUI and I am going to select downloads, go to downloads, click on this file, right click, and I'm going to say extract here. Okay, so after extracting, I'm going to right click on the Frida server and I'm going to rename, and I am just going to name it Frida server and press enter. So now we have the Frida server. It's on our intro to Android security virtual machine. Now remember, we're connected to our emulator and we need to bypass the root error message on the emulator. So we need to move this file to the emulator. How are we going to do that? Well, we're going to say adb push, which means push the file in question, which is going to be Frida server, and we're going to say push it to data local temp. And this data local temp is inside our Android emulator. So if we press enter, it pushed successfully. So now, and we can see that one file pushed successfully. So now we have our Frida server. It's currently in our Android emulator, but it's not turned on. So how are we going to turn it on? Well, we need to activate some things in the ADB. So first, what we're going to do, we're going to say we're going to say ADB root. And what this does is we're going to start ADB as root because we're going to need that again because we're going to modify the Frida server file and we need to be the super user to do it. Next, we're going to say ADB connect 192.168.1.92. So we're going to reconnect back to our Android emulator. Now we're going to say ADB shell. We're going to open a shell. Now we have a shell because we can see it here. We're going to CD to data local temp, which is where we pushed the Frida server. Now we're going to do a ls and we can see the Frida server is there. And now what we're going to do, we're going to say change mode 755 Frida server. So now what that does, what we're saying, 755 represents permissions. So permissions in Linux or in Windows tells you what you can access, what you can read, open, write, modify, execute, execute as in run. So in this case, the Frida server has read write for owner, owner is shell, read write for group, group is shell, read write for everyone else that is not the owner and not in the group. So now with change mode, we're changing the mode or changing permissions to 755. So you may be wondering, okay, how does that correspond to the read write that you just mentioned? In Linux, read is 4, write is 2, execute is 1. So 4 plus 2 plus 1 is 7. So in this case, the owner is going to have read, write, and execute privileges. 5 for group represents, again, read is 4, write is 2, execute is 1. So that specifies group can read and execute. And the same for other. They can read and execute. So to prove this, we're going to say ls-la. And we can see it here. Before we had read, write, read, write, read, write for everyone. Now we have read, write, execute for owner, read, execute for group, read, execute for other. So now we're going to start Frida in the background. So we started Frida and now the ampersand in this case says started in the background. And now we have this number here, 5058. What does that mean? 5058 is the process ID. So it's saying, hey, the Frida server is now running with process ID 5058. In Linux, everything has a process ID. So in this case, Frida server is like, if you need to reach me, 5058, that's my ID. Okay, so I had technical difficulty, so I had to start over again. So I did the ADB root, connect again to our Android emulator, executed the shell, but now I did something different. I executed su to act as root inside the command terminal. I changed to the data local temp. I didn't need to update our permissions because I did that before. Well, I did it again just as a sanity check. Next, I changed ownership because right now it's shell. So change own is another command in Linux. And I said I want the user and group to be root for this file, Frida server. I did another ls listing to make sure that was correct. And then I started the Frida server in the background. So now we have a process ID of 3088. So now if I say Frida PS -U, okay. Now if we scroll up, scroll down because I'm looking for it. Yes, 3088. So 3088. So our Frida server is now running. So we connected everything successfully. So this Frida PS says, hey, for Frida, find all of the process IDs that are using Frida. And again, our 3088, did I pass it? Yeah. Our 3088 is our Frida server. And we can prove that here because it matches this process ID here. When we said, hey, execute Frida server in the background, that's what this ampersand is. So we have connected successfully. Our Frida server is talking between our intro to Android security virtual machine and our emulator. So good, we're good. Now, we have connected the Frida server, but we're not done yet because we need to actually do the dynamic analysis. We need to change the values. So what we're going to do now is we're going to reopen the UnCrackable level 1. And yes, the root detected, that's what we want. But this time we're not going to press OK. We're going to leave it. And we're going to go back to the documents folder. And remember, I said I created 2 files. So Frida is a dynamic analysis tool, and you program the bypass checks you want to do. You could do it in JavaScript or Python. I'm using JavaScript. So I'm going to open this file and I'm going to explain what we're doing. So remember, I said our Android applications are developed in Java. So what I'm saying is, hey, I want to do a Java perform, a function, and I want to say I want to create a variable. That's what this var is. Create a variable named app class. And I want to use the package sg.vantagepoint.a.c, which corresponds to this class. So it's like, hey, I want to access the methods in this class, which will be A, B, and C. Next, I want to say, okay, I'm going to do the A method first. So what I'm going to say is, hey, app class, I want to implement, or I want to re-implement this function. So I'm going to create a new function, f, and I'm going to display to the screen in function A for Sue, which lets us know, hey, we're in this function because we're looking for Sue or switch user. And what I'm going to do here, I'm returning false because remember, these checks, if we're Sue, return true, which means we're rooted. So we want to return false because we're still going to be rooted, but we don't want the flag to go off. We don't want this check to go off. So instead of having true, we're going to set it to false. And the next method is, hey, we're using the same variable app class. And now we're saying, hey, let's go to the B function. And we're going to re-implement that class. And we have a console log and it says in function B test keys, which corresponds to this method, test keys. And we're saying return false again. So if the string is not null and we have test keys, we want to return false because we don't want the flag or the check to catch us because we are rooted. Next, and finally, we have the C method, which corresponds to this method here. And we're saying, hey, app class, the variable we created here. Let's go into the C method. We're going to re-implement that method, and we're going to display to the screen in function C super user file, because it's a whole bunch of files, and we're returning false. So it's like, hey, remember with OR statements, A or B or C needs to be true, meaning one of these has to be true for the root detection to kick off. So if we change all of these to false, then the root detection will not kick off because all of them will be false and the conditional will be false. And if we go back to the main activity, if it's false, it would create. So it would skip this and it would just go to actually creating the application. So, and then we have a final display to the screen that says changes complete to let us know, okay, we did the changes for A, B, and C, methods A, B, and C. So now we have Frida, it's working, our server is working. We're connected to our Android emulator and we have root detected. So now we need to actually tell Frida, hey, use our code. And now we're going to tell Frida we need to tell Frida, hey, you need to use our code, this disable root. You need to use this because we need to bypass this check here. So how are we going to do that? Well, I'm going to show you. Going back to our terminal, we're going to say Frida PS. Oh, first, before we do that, let me say Frida PS -u. So now we see that Frida has captured our OWASP.mstg.uncrackable1 process, and it's using the process ID of 3164. So we're going to need this, and the reason we're going to need this coming up, and the reason why Frida is capturing this is because, well, we have the application open in our emulator. And the Frida server is working. It's currently enabled. So now we're going to say, hey, Frida, use our disable root.js file. So we're going to say Frida PS-u, no pause. And then we're going to specify where our disable root file is. So it's going to be home, Android, documents, disable root.js. And then we're going to say -f for file, and we're going to say OWASP.mstg.uncrackable1 because we want to go to our uncrackable application that is open. Pressing enter. Okay. Oh. It's not Frida PS, it's just Frida. Okay, we see our changes are complete. So it executed successfully. Now, if we go back to our app, you see we have successfully bypassed the error message that we're getting. We're still rooted, but we have successfully used Frida to bypass the rooted check here. And we did that by changing all of the methods to false. So again, Frida is very powerful. And as I said, you can use this while the application is running to change values on the fly. Okay, so part one is done, but we're not done. We're not at the finish line yet. So now we have removed the root error, but we don't know the secret string. So how are we going to get that? We're going to go back to our JADX GUI and we're going to scroll down and we see we have a verify method and we see we have some more obfuscated code and it's like, hey, A.A of object. If this is true, success. This is the correct secret. So let's go to this A.A. Okay, so now we're in the sg.vantagepoint.uncrackable1 package, and we're in the A class, which is public, which means it's accessible to everyone. And we have another Boolean of A, which is public, which means it's accessible to anyone. And we're passing in a string. And in this method, we have two arrays. That's what these brackets are. B array and B array 2. And looking at B array, we see that we have this method B, and we're doing some decoding of a value. And method B is here, and we see we taking in a string. We're getting the length. We're doing a whole bunch of stuff. But we notice we have this A.A.A. And if we click on that, we're in a new package, sg.vantagepoint.a. And we see here, this A method is taking in the two arrays we have, byte array 1, byte array 2. And we see we have a secret key spec, and we're using it for the byte array, and we're using AES, or Advanced Encryption Standard. We have the cipher, and it's like, okay, we're using AES, and then we're initializing an instance of the secret key spec, and we're returning that instance of the second array. So essentially, we're doing the encryption of the AES of byte array 1, and we're saving it in byte array 2. So I wonder if we can use Frida to essentially do a keylogger to get the passcode. Well, let's see. Okay, going back to the documents, I have a disabled root 2 folder. And if we look at this folder, this file, we see that we have additional code. So we have a function bin2string of an array, and we've declared a new variable result. That's the empty string. We're doing a for statement, so for I, which is another variable we created, we're starting at 0. So for arrays, they start at 0, index 0. For I less than the length of the array, we're going to increment by 1. And what we're doing is we're constructing the result from the current array index. And what we're doing is we're taking that value, that number, and we're changing it to a string equivalent. That's what this string.from_char code means. It's a number, and we're going to change it to its letter equivalent. And we're going to return the result. Here, this code is the same. This is to bypass the root check, so we're going to keep that the same. Here, we're getting the passcode. So what we're saying now is we're going to create a new variable, pass class, and we're going to say, hey, use sg.vantagepoint.a.a, which corresponds to, this class and this package, sg.vantagepoint.a.a. From there, we're going to say, okay, we're going to re-implement the A class. And here you see for the function, for the others, we had just one f, or one parameter. Here we have two x1 and x2, which corresponds to our byte array 1, byte array 2. So we have two parameters in our function. Next, we create another variable, pass function call, which is a blank array. That's what these brackets are. Then we're going to say the pass function call to this .a of x1 and x2. So what we're saying is for this instance of the a function, for x1 and x2, we're going to save that to pass function call, which is, and remember, pass function call is a blank array. Next, we're going to say we have a new variable output, and we're going to assign that to bin2string pass function call. So essentially what's going to happen is pass function call is an array, which is also an instance of the A function, the current instance of the A function of B array 1 and B array 2. And what's going to happen is it's going to call this function here. It's going to call this function here, and as we're typing, it's going to get the letter equivalent. And then from there, we're going to output to the console the output, which again is going to be our passcode, and then we're going to return pass function call. And you may be wondering, why are we returning the array? Well, if you look back into our class A, we're actually returning an array here, byte bracket. The brackets are an array. So we need here to return our array. If we don't return an array, we will receive an error. So that's very important. Here, we're returning false because for these methods, it's a Boolean. So so for a Boolean, it can only be true or false. In this case, we want them to be false because we want to bypass that check. So I want to make clear distinctions on why we're doing things the way we are inside of these files. So now what we're going to do is we're going to exit. And we're going to rerun Frida, and instead of disable root, we're going to say disable root 2. And our and our changes are complete. But to actually invoke our keylogger, we need to go back here, and we just need to type anything. So I'm going to type test, and I'm going to click verify. Nope, that's not it. But if you look inside of our console here and on the screen, we see the passcode. I want to believe. Success. So we have successfully solved this challenge. We found the correct secret. So we've done a lot in this video. We've done a lot in this video. We looked at the intro to Android security. We talked about that a little bit. We looked at how to reverse engineer an app using JADX GUI. From there, we had the root error message. We couldn't even access the application. So from there, we reverse engineered the app, started looking at the code. We found where the root logic happened. So then we again realized we had to use Frida or a dynamic analysis tool to change the values on the fly while the application was running. And we did that by by re-implementing the functions and having the values return false. So that way the root check would be bypassed. We showed that and it worked. Finally, once we had that first part down, second part, we needed to actually find the correct string. We didn't have it. So then we had to go back to the code, look again, scroll down, look at the verify method, and look to see how the string is being compared. We created a keylogger of essentially every time you type a letter and press verify, you type a word. In this case, I typed test, press verify. I knew it wasn't correct, but it output our passcode, which was I want to believe. And typing that again, we see we have success because this is the correct secret. And as you can see, it did it again. So it's always going to do this. Every time you type in something, it's going to do the passcode. So we have done a lot in this video. And in subsequent videos, I will be looking at how to solve additional Android security vulnerabilities. I'm only looking at Android because the barrier to entry is fairly low. So I can't wait to see you in my upcoming videos. I hope you learned a lot. I have the link to my virtual machine. It's on SourceForge. I have the virtual machine intro to Android security version 2.0.1, as well as the Android x86 virtual machine. Again, I'm trying to make this as accessible to any and everyone who wants to learn about Android hacking. And I can't wait to see you in my upcoming videos. Have a good day. Bye.